Okay. So good morning, everyone. I'm Wei Jiaxu. Welcome to our lightning talk series on smart city research. And this talk series is funded through the UT's Good System project. So we invite speakers from academia, industry, and the communities to share research advance and the needs related to the smart cities. So if you are interested in this topic, please feel free to visit our website for our past talks and other activities at smartcity.tech.utexas.edu. And for today, we are very excited to have Dr. Sasha Dong as our guest speaker. Dr. Dong is an assistant professor from industrial engineering at the Texas State University. Her current research focus is on applying and inventing data and computational science methods to improve the efficiency, effectiveness, and the equities of disaster response and crisis management. She is a recipient of NSF SAIS CRII Awards and has been selected as a NSF OSIR ECM Program Fellow. Her talk for today is titled as the Social Media Information Sharing for Natural Disaster Response. So without further ado, I will pass the mic to Dr. Dong.
Thank you very much for the introduction, Dr. Xi. Good morning, everyone. Greetings from Santa Monica, California. So I'm very happy to be invited to this great seminar series and feel excited to share some of our recent research work. So the presentation here today is actually about one paper we published on journal Natural Hazards, and we may not have enough time to go over many technical details. So I will provide a reference of the paper at the end of this talk, just for your interest. And one of the co-authors is my colleague at Texas State in Health Administration, and he is actually long haul as well. So today's talk consists of 4 parts. First, I will provide some brief introduction about my research interest in general and the motivation for this project. And then I will talk about how we collected those data from tweets and what kind of analysis we have conducted, what would be the interesting findings. And then I will go to the machine learning models and the 8 different machine learning and deep learning models we implemented and what operational insights we could have for the relief agencies. And then I will quickly summarize my presentation today. So I have been working in the field of disaster operations and emergency management for a couple of years. I personally think this direction is very interesting, and there are a lot of challenging research issues worth exploring. But more importantly, the research output would have significant societal impact. This is a map provided by NOAA. Showing all the billion-dollar weather and climate disasters occurred until the past September for year 2021. You may know or you may not know, actually have a lot of natural disasters occurred very often. And we already have $18 billion natural disasters just for the past 9 months. So efficient and effective disaster planning would be very important. And with the development of internet and mobile technology, social media platforms have become a very promising and significant channel for posting, receiving, and sharing information. And those platforms have very obvious advantages for the use of disaster management. For example, we could have the real-time two-way communication, and the information online there is vast compared to the traditional way, communication methods like phone call. So that's why you can see there is an increasing interest on the application of social media for disaster management, both from the perspective of researchers and practitioners. So people would like to see how we could take advantage of those social media channels, or how we could leverage those social media data for better disaster management. people study social media data from different perspectives. Some of them focus on the geographic location information, such as the coordinates those users posted on Twitter. And for our project, actually, it was motivated from the collaboration with local relief agencies. They were interested in knowing how they performed when they were there to help and support disaster, how the general public's attitude towards their disaster planning, and what important or what useful information we could collect from the social media data, and also for different types of disasters, not only hurricanes, only take Texas for example. How about the storm, right? They have different experience, different expertise, and how the general public actually reviewed their work. So that's some background of our project. And we started this project based on the Twitter data. And the first thing we did is actually we want to identify what disasters we want to look at. As I mentioned earlier, that to the best of our knowledge, most of the existing relevant work, they only look at some particular disaster like Hurricane Harvey. You can find a lot of relevant work about Hurricane Harvey, but there lacks a gap that relatively comprehensive review on different types of disasters. So the first thing we did is actually to decide what disasters we want to study. We look at the Wikipedia statistics over the past 10 years and selected the various types of disasters that are most destructive and most costly. So there are tornadoes, floods, blizzards, hurricanes, and wildfires. And since hurricanes are one of the most occurred disasters in the United States, and we have relatively more experience of dealing with hurricanes. So we also want to look at how those relief agencies performed for different hurricanes. So we actually look at the data from two angles, different types of natural disasters and a set of similar natural disasters, which is hurricanes here. And we use different keywords for those disasters I just listed. And we define the duration of the disasters following Wikipedia definition. But meanwhile, since we know people will actually start sharing information before disasters arrive, and they will still they still kept posting their comments, their thoughts after disaster were over. So we actually the time frame we collected the data include 1 week before this disaster occurred, and then 1 week after the disaster was over. This is how a tweet. This is like the Twitter platform, and this is how a typical tweet looks like. And the raw data we collected using the Twitter Scraper API looks like this. It contains a lot of important information, and for our project, we only focused on text and timestamp as highlighted here. So based on the needs that the relief agencies provide, so it is actually about sentiment analysis, which means that we want to identify, study, and quantify those effective information, how the general public's attitudes, opinions, or thoughts towards the relief agencies' disaster planning or disaster operations. And we actually need to use the machine learning models to predict those attitudes, considering the large amount of data. But we need to feed the models, right? So which means that we need to label the tweets. So we consider two different types of tweets, positive and negative. So positive means that the general public were relatively satisfied about the help, the support they received from those relief agencies, and the negative means the other way. And this is some basic analysis. It is not very surprising to see that most comments or most attitudes were negative. But there are still some interesting things we can observe. For example, if we look at hurricanes here, in general, we had relatively more experience of dealing with hurricanes, and the hurricanes are more predictable. So the relief agencies could start their work ahead of time. They could do a better preparation for hurricanes. And meanwhile, like blizzard or maybe wildfires, and and also let's say the storm we experienced in Texas this February, it came relatively suddenly, and we did not have those kind of disasters very often. So you can see that the percentage of negative comments were extremely high. And if we look at the numbers of positive and negative tweets, as well as the percentage for even the similar types of disaster, which are hurricanes here, there are still different. There are still quite differences. Although Harvey is one of the most costly hurricanes in the United States history, but actually, with the relief agencies had did an excellent job on helping people, providing the resources, helping them evacuate as soon as possible. It showed alerts ahead of time, and there are still a lot of room to improve for other types of hurricanes. Sandy, for sure, Matthew, Michael, among others. As I mentioned earlier, that relief agencies also want to know what other information they could get from social media data. So we actually look at what essential supplies the victims usually need based on the information they shared on Twitter. And we focus on the essential supplies because of a few conversations we had with local food banks. For example, they mentioned that when hurricanes arrived, they always have a lot of volunteers were eager there to help. They donated a lot of water, like gallons of water, but actually most of the time the victims in the affected regions don't need water that much, because waters are always something they will store first already. And the gallons of water actually were very hard to transport to those disaster affected regions. So waters are not the top one priority. So that's why we want to study what essential supplies they actually need. And we found out that it's a little bit a surprise, I would say, transportation. Not only for hurricanes, but for other types of disasters, transportation is the #1 need from the victims. But for different types of disasters, they have different needs. Like tornado, they need housing more, most of the case. And for wildfires, they need both transportation and the food. Most of the time, the medical supplies are, we don't have very severe, impacts on some people's health or life. So medical supplies are among the least of the supplies they need. And even for the different hurricanes, they have different needs here. We also did some studies to look at the time. So it's here, this one. Look at the time pattern when people posted the tweets. We want to also explore, the role of social media platforms, how during the disaster response. And we found out that we look at how people posted before disaster, during disaster, and after disasters. And we found out that it actually depends on the nature of that emergency. For example, the wildfires here for 2018, wildfires are relatively, less predictable, and the time window that we need to respond to wildfire is relatively short. So you can see that people may maybe busy with evacuation, and they started sharing information later after the wildfires. So actually, this gives the insight to the relief agencies that this should still monitor those social media platforms even after disasters were over, because there are still a lot of, many things we need to do for disaster recovery phase, and there are still a lot of, useful and important information shared by the community. Machine learning models. So for the sentimental data analysis, we actually conducted we implemented different machine learning and deep learning models to do a prediction. So this is the general flow for the workflow for the sentiment analysis part. We already described about the data collection, and also we need to clean and pre-process the data for better accuracy, and then feed the data into the learning models, do the evaluation, and then do the prediction. So we clean the data following, the conventions that we remove those actual information, the special characteristics, and convert the letters of each word to lowercase for simplicity. And then we also need to, this is a small challenge here, we also need to convert the category data into numeric value. So the technique we use here is TF-IDF technique, so that we could have different future vectors to fit into the data, fit into the different learning models. And we tried 8 different learning models. So most of them are machine learning models. A few are deep learning models based on the literature we have explored from literature review work. And we did a comparison among all these 8 different models. We look at the accuracy of the classification. And the interesting finding here is the naive Bayes, one of the simplest machine learning models, actually work quite good on the data we collected. Oh, by the way, the data we collected is about 42K tweets in total. So it provides relatively high accuracy for both different types for all the different types of disaster here. And I did not post the table in today's talk, but we also checked the precision and the recall and F1 score as well. And turns out that naive Bayes is always the best. And considering there is the imbalanced data, we actually did a comparison based on the ROC AUC value as well, which is receiver operating characters area onto the curve. And it is a little bit surprising that naive Bayes still works the best. And if we also look at the computation time, some of the complicated models like KN, the deep learning models, actually is very time consuming. But meanwhile, those simple machine learning models work quite good also in terms of the computation time. So this is actually this is a good sign from our perspective, because machine learning models like the naive Bayes or even largest regression or decision tree are relatively easy to implement. And it is easy to interpret for the first responders who do not have too much technical background. So a quick summary. So for the project I shared today, it started with the collaboration with the local relief agencies. They wanted to explore the general public attitude towards their response planning, their relief plan. And those agencies want to know what particular needs in terms of relief supplies for different types of disasters. And to the best of our knowledge, most of relevant work about social media data in machine learning in disaster response, they only focus on one or maybe two most the disasters. But for our project, we actually look at different disasters to explore the role of social media information in disaster response. So here is the reference for the paper that we published on Natural Hazards. And also, if you are interested in our data, we actually share the data publicly on archive as well. So that's all for today's presentation. Thank you very much, and I'm happy to take any questions.
Thank you. I think that's a very interesting talk. I will wait to see if there's any question from audience. But one question I want to throw out first is we also have been working a little bit on the natural hazard data in general in our like in tech, and we have run a little bit text mining through the natural disaster papers and the research. So one thing we found is, especially when we talk about social media, is sometimes if you're just interested into the like people's opinion, that's probably easier. But if you want to really say extracting more useful information from social media posting and helps in like say pinpoint location or assess damage, that's what I think. Then there's always a kind of the barrier between different terminology like a general public will use versus what the domain terminology will the responders or researchers will use. I don't know, have you met such issue or have thought about more about what's like from natural language processing point of view? Is there any solutions?
That's actually a very good question. So I agree that there are a lot of information we can, explore from social media data. So that's why we also did the analysis for, the possible resources we could support the victim when the disaster arrived. I don't have a very good question to. I don't have a very good answer to your question. But another challenge actually I want to mention here is the language setting. So I don't know whether you met this challenge when you did social media data mining. Is our knowledge is only about English, right? So we can speak English, but we don't understand Spanish. That would be a challenge, and for hurricanes particularly, because they will affected most of the coastal regions, and there is a large population who only speak Spanish, and even for the tweets or the other information they posted on social media platforms were in Spanish. So that is actually another challenge we met when we had such kind of project.
Yes, I understand that part. So yeah, but I think like right now, like there are library like the Spanish language based NLP library is pretty good too. So it's you can just as long as you can distinguish them out, you can do the same thing you will do with the English language model as well, right?
So you should be able to collect the Spanish tweets from social media, or let's say from Twitter, but you may not be capable to interpret those textual information. And I did have the conversation with some of my colleagues from computer science department, and those existing translation dictionary actually are not very reliable. So yeah, that's
okay. So Dave, do you have questions?
You are muted.
Yeah, thank you. This is really interesting. Thank you for this talk. My name is Dave Nyogi. Our lab does a lot of severe weather simulations using different kind of models, both for tornadoes, thunderstorms, hurricanes, landfalling systems, and so forth. We have always thought somehow we can use the tweets and the output from the tweets to compare the simulation results to try and see the validity of the findings. Because under the severe storm conditions, availability of observational data to compare against the model fields is extremely limited. It sort of goes, it's a question both to you, Sasha, and to Vijay. How can this be made possible? Looks like there's tremendous expertise here. And if we generate, say, for instance, different storms, both for landfalling as well as for the thunderstorms or tornadoes, And if we can generate different ensembles by looking at different parameterizations or different start time, different resolution model settings, and the question often comes up, which one is more reliable? Is it possible to use the tweets to comprehend on the quality of the model results?
So let me try to understand the question you asked. So what would be the data or feed into your simulation model?
So in the output, like right now, when you're saying you have a hurricane, or when you're saying you have a thunderstorm or a tornado, you have some location where this thing occurred. You have a track from where you can look at it. This is sort of in the post-mortem mode. But when we are doing our predictions of these events, we have a potential, where you might have seen it for hurricanes, for instance, where you have that cone of uncertainty. The system can go left, system can go right, it can stall, it can veer off, it can speed up, and it could even have different characteristics. So we can generate each of those scenarios by our model runs, but how do we evaluate them is the question.
Yeah, so I think so from my understanding, I think you could use you can go back to check the data during the disasters to validate the model, right? So if it is if the data you need is about geographic information, you actually can look at the coordinate posted or shared by tweets to see whether it could whether your model actually could work well on those situations. Did I answer your question? Or?
I can follow up with you more. This is really interesting topic, and there seems to be a potential because we are doing both a climatology as well as prediction, and you can do some of this. Vijay, you have any thoughts?
Yeah, I just want to quickly add, I think if I understand your question correctly, that's actually tied to my first question as well, because like we have done a couple of the social media analysis, Twitter analysis with it as a different context. But one thing we found is harder is to really join information we can get from social media with actual academia research information. So I think that's part of the question you were trying to aiming is how we may leveraging say social media help us to do the validation or help us to do evaluation. But we do need to finding a way to integrating the information we extracted from social media and information we required from the academia settings are the same. They can talk about same language. So for us, and what we see is I think like most of our information may coming from the metadata from the social media posting rather than content itself, because the content usually is not what's not in a academia domain, if that makes sense. Like let's say if we do COVID, right? So we want to using tweets to see if we can track the COVID transmissions things, but what you get from COVID from content wise is going to be very differently to mapping what's the terminology the researcher or doctors will see and will make judgments with.
Right. See, Vijay, I'll give a specific example. When I was the state climatologist, I had to do drought declarations. And one of the factors we used to look for is how many tweets related to drought or drought related water scarcity, dry conditions were starting to come up. And then we could use that to sort of confirm with on the ground people, is this really a problem? And use that to actually make that particular county a higher intensity of drought. That's one real example about how the social media data actually gets into the forecast and improves the forecast of what it might be. But in a more shorter term time scale, like a hurricane or a thunderstorm, how do we use this is a challenge. And I would love to hear some thoughts maybe in a post-mortem. But thank you for this presentation.
Yes, thank you for the question. One thing I want to add a comment is social media platform right now. I agree with Vijay. This is actually one thing I want to point out as well is you probably will have about the data relatively because and also with like limited population, especially you may not be able to cover those vulnerable population who don't have the access to the internet or maybe just don't use Twitter or the social media channels very frequently. So from my perspective, social media platform could provide, the supplementary data, but we should not rely on that for, for everything. Another comment to which is the issue which I mentioned earlier, that actually we have another ongoing project that is look at the social media misinformation. From the operational perspective, I know there is computer scientists work on the misinformation, but that is from from different knowledge of domain of the knowledge. And from our perspective, we would like to look at how those relief agencies could kind of distinguish those misinformation, particularly for COVID, and then how to kind of combat that to post the relevant authoritative content to educate the public to better for better disaster emergency management.
Okay, very interesting. So we're already at the time mark. So I want to stop here. If you have more questions, please feel free to reach out to Dr. Dong directly, and you can see her email here. And if you miss it, and you can feel free to send us email, like we're happy to connect you with Dr. Dong as well. So thank you very much, Dr. Dong, for your wonderful talk, and we will post the videos and on our website. And if you're interested in the future talks, and you are also welcome to visit our website at smartcity.tech.utexas.edu and to see our past recording and any future talks. Thank you, and have a good weekend. Bye.
Sounds good. Thanks for having me. Have a good one. Have a wonderful weekend.